Christmas time is a fantastic time of year for so many people. One thing that can make a child's Christmas even more special is when the toys that they receive make them feel represented and valid within the world they live. For children with medical devices such as shunts, pumps and hearing aids, for example, finding toys that also have these things can be a little bit trickier. Now, with the magic of 3D printing, it's possible to design and create toys that are completely unique and tailored to an individual. To learn more about the process, I spoke to Nick Harmon, who runs 3D Toy Shop, to learn more about how 3D printing works and the things he's been doing to help bring a little bit more joy for children this Christmas. It's nice to talk to you, and I really love what you're doing with your project. So how did you get started with it all, and what sort of things have you done so far?
Well, rewind back to the start of COVID. I do industrial automation software for a living.
Yep.
And I was due to travel out to Holland to work at Philips to do some the machine that makes baby bottles. But the trip was cancelled because lockdown happened, and then I lost like a lot of my work. So yeah, I'm like, okay, well, what can I do? Global pandemic, time to do what I can. So I'm like, right, I'll start making face shields and ear savers. I got more 3D printers, and then, yeah, I've made stuff related to COVID until the 4th of October. And then when I saw face shields in Aldi for £2, I'm like, there is literally no point in carrying on this. So I thought I'll use my 3D printers and try make some stuff for Christmas presents, you know.
And then how did that turn into doing accessible toys, or the sort of toys where people with medical issues can feel more included with the things like the shunts and the insulin pumps that you're making?
So I started saying, well, I'll make any toy. You tell me what you want, and I'll make a toy. And then a lady got in touch and said, can you make a toy for my 3-year-old boy? He's got a brain implant. I'm like, oh my God, that's like, I don't know, I just felt a connection with it.
Yeah.
So I spent like a full day and designed the Teddy shunt valve, and yeah, I shipped it to her, and she loved it. And all of a sudden I was inundated with messages and requests, and they're saying, oh, can you make this? Can you make a cochlear implant? Can you make an insulin pump? Can you make a shunt? Can you make a foot splint? And all of a sudden I had all these requests to make all these things, and I'm like, well, why not?
And just for anyone who isn't familiar with 3D printing, in a nutshell, what is it?
So I'd say the easiest way is, if you imagine you get a glue gun and you draw a picture and then raise it up a millimeter and then draw another picture, raise it up a millimeter and draw another picture, eventually you've got like a 3D object, which is like a stack of 2D images. As you can see, I've got a multicolour print going on there. And how that works is you have 2 rolls of filament, and then it goes through a pipe into here, and yeah, it's a multicolour print.
And I think the great thing about 3D printing is it allows anyone who has the knowledge to use the software to design and create things from scratch, meaning that you can make toys or other pieces of equipment that otherwise would have been impossible to make. How long does it take you to go from an idea, so say with the shunt, to actually making a finished product?
Well, the shunt, that took about half a day. There's a couple of different parts here. How long does it take to 3D model something? And then how long does it take to print something? So a lot of stuff that you want, you don't have to 3D model. 3D modeling is like a complex skill that you've got to learn.
Yep.
But there's a whole library. There's like hundreds of thousands of items that you can literally just download offline and print. But the time to print, it depends on the size. Like a shunt valve takes about an hour to print, whereas this guy, giant Lego man.
Yep.
He takes about a day and a half to print.
Sure.
So it depends on the design, depends on the complexity and your skill, and the printing depends on how big it is.
When you're designing something, how do you make sure that it works with, say, whatever toys the child may already have, or that it's also child friendly? Because we know kids have a habit of putting things in their mouths and
Yeah, so at first I didn't have any awareness or any knowledge of this. I just started, oh, Teddy shunt valve, I'll just make one. But then when I had like over 100 requested, I'm like, I'm going to be sending a 3D printed item to over 100 vulnerable children. This needs to be safe. So I started reading about toy safety, and then I invented this. So I can take something that I've 3D printed and see if it fits in here. If it fits in here entirely, it's a choking hazard.
yep.
So I'm trying to make sure that everything I make isn't a choking hazard.
And I think you've been going through the process of certifying some of the things that you've been making so that you can share them on a wider basis. What does that involve to get that certification?
To sell in Europe, you've got to be compliant to a standard called EN71.
Yep.
There are 3 parts to EN71. It's got to be mechanically okay, like it's not a choking hazard. It won't shatter and cause sharp pieces. It's not a strangulation hazard. There's a whole bunch of tests required for EN71 Part 1. For Part 2, you've got to make sure it doesn't flash up into a ball of flames. And for Part 3, you've got to make sure it's chemically safe. Like there's no poisonous metals and stuff like that in it. So with the Teddy shunt valve, I didn't do any of the tests myself because I'm a 3D printer, I'm a hobbyist, I'm a programmer. I thought, you know what, I'll just pay the lab, I'll let them do all the tests, and they'll tell me if it's safe or not. So it was about 350 quid in lab costs, but I've now got a document that says the Teddy shunt valve is safe as a toy.
And what plans have you got for the future in terms of making these toys or devices, in both with the Teddy shunt valve and also with the other things you've been making?
I realise there's a massive shortage of people actually making these inclusive toys. Like children need to identify with and normalise these conditions. So it's kind of like how can I share them? How can I make people aware? So I'm trying to make a website where it will detail this is the story of the Teddy shunt valve, how it came about, what it is. A lot of the other toys, like the teddy bear insulin pump and the cochlear implant, there's already companies that are making them. So they're not like completely new, which is why when I shared them, I might only get like a few hundred people commenting. Yeah. Whereas the Teddy shunt valve is literally the first toy in the world for children with hydrocephalus. So that just went completely crazy.
And if parents stumble upon this and they're interested, maybe they've got a child with a different kind of device, what should they do if they're interested in perhaps something for their child?
So I'd say, first of all, go to the Facebook page, facebook.com/3D Toy Shop. Maybe send me a message, or go to the website, www.3dtoy.shop. That's a Google form. You fill that in, and I'll get back to you. I'm really busy. I'm completely overwhelmed. This is a part-time hobby, but I will get back to you, and I will design a toy, and I will make it for your child.
It's a fantastic project, and I think the unique thing is that 3D printing means that you can really tailor and design what you're making to the needs of the people who are using it.
I think the thing that I'd say is 3D printing is a technology where you can literally make one of an item. Like for a typical toy, you'd have to get it injection molded, and that'd cost like £8,000. Whereas 3D printing, there is no barrier like that. You can literally design your own toy and print it yourself. And if you can't design a toy, you can go onto like Fiverr.com or go to a Facebook group like 3D Printing UK, send a message, and someone will design it, and then someone else will print it. And like the cost of making little toys, like this is the teddy bear cochlear implant. It was about like 4 hours work to design. It's about 50 pence worth of plastic. You can ask people to make stuff, and there is no upfront cost like the big toy industry. And the thing that completely blows my mind is the fact that you can CE mark this stuff. It can be safe for not too much money. There's no thousands of pounds barrier like there are with the typical toy industry, and then you can have a product which is going to normalize and represent for many children, and I think it's a game changer. I have actually had a bunch of requests from children's doctors.
Okay.
Because apparently, like, they struggle to explain what a shunt valve is to patients.
Yeah.
There is no physical thing; it's just a concept and a diagram. And they're like, "Well, what you've got is a toy that explains it in a non-threatening way."
And
so
we do it all the time. Like, children are used to stethoscopes because it comes in their toy doctor set, so they're not scared of a stethoscope. But things like, oh, what's this shunt that's going to be in my head? And it is a scary thought. And how having toys enables us to explain things and make things less scary, and it's such a useful tool.
Well, it was all designed for one little boy. It was just, this poor fella has got an implant in his brain. Oh my God, I feel so sorry for him.
Yeah.
So I designed it, and then 200 quid in donations kind of compelled me to certify it as safe, refine the design, change the material, and
I think that's sometimes how the best ideas come about, isn't it? When you suddenly find that there's a need for something that nobody else has met before, and you're not trying to do something that other people have already done. You're not reinventing the wheel. It's using the skills.
I invented it for the one boy. That was it. I didn't know what hydrocephalus was. Like,
I think I'll wrap it all up there. But yeah, it's been really interesting hearing how it all came about, and all the best.
Thank you.